terms and how to put a few of these things together, okay? So the first thing it is, whenever you're dealing with logs, you want to know how to work with two things. What we call an exponential form and what we call a logarithmic form. Okay, logarithms have been around for a long time. We used to use them a lot to simplify calculation a lot before we had calculators, because we could change things into decimals and use some basic properties that helped with calculation a lot, like a slide rule. You go back to the 60s, engineering students all had slide rules on their pocket. Okay, there was no calculator, so you could tell an engineering student by their slide rule, and they're based on logarithms. Okay, what we're going to learn how to do is just how to change these from one form to the other. So in this case, this is a log form. A couple of things you want to be aware of is the answer to a logarithm is an exponent. It's just another way of rewriting something. So if you write this form, what you say is you say that base, that 10 is the base. So what you say is you just write this as 10 to the third is equal to 1,000. Okay, these are all in log form, so you have a base, you have an exponent, you're creating an exponential expression. Okay, so if you have an ln, what does an ln mean? Base e. Okay, that's base e. So I'm going to have you just rewrite that like that. Anytime you see ln, that stands for logarithm naturel. Okay, it's a French thing. So it's a natural logarithm. So what you say is e to the 9th is equal to x squared. Okay, again, this number right here is your exponent. Answer to a logarithm's exponent. You'll hear me say that a lot, because if you're doing a logarithm, you're thinking about an exponent. Okay, what's a log? What base is that? 10. Okay, so that's base 10. So you want to know that log is base 10, so you would go like that. Okay, if you're going to write that in exponential form, then your base is 10, your exponent is z, that's equal to x plus y. Okay, so you're always just rewriting those in that form. Okay, then the next one you would have log base e, and you don't have to write that down. I just want to show you what you're doing. So what would that be in exponential form? E to the x squared is equal to 4. Okay, so e to the x squared is equal to 4. Okay, again, your base is e, your exponent is x squared, like that. Okay, so you got to start this way when you're learning logarithms, is how to rearrange and write these things back and forth, because you'll do this all the time. Okay, so let's do these backwards and kind of work with this then. So if you have it in exponential form, then it goes like this. Okay, the 2 is the base. Okay, the 3 is the exponent. So now we're just putting this in log form. So what we would say is log base 2, because that base is 2. Remember, the answer to a logarithm is an exponent. So you would say log base 2 of 8 equals 3. Okay, just think about what the base is and what the exponent is. Okay, same thing on this one. This would be log base 10. The answer is the exponent 4 of 10,000. Okay, so that's how that goes. Now, what's the other way to write log base 10? Just log, exactly. So you would have log of 10,000 is equal to 4 like that. Okay, that's how that goes. Okay, the next one, you would say log base e. The answer is the exponent of a. What's the other way to write log base e? ln. Okay, so you would just say ln of a is equal to b would be how you rearrange that like that. That's the idea, okay? And then the next one, what's the base of the logarithm? A. What's the answer to this? Whatever the exponent is, x plus 1, and then the c goes there. Okay, just think about the answer to a logarithm is an exponent, and then the base is the base of the log, and that'll help you remember that, okay? All right, let's do one little thing on the next page, just a couple of things, and we'll be done here. So just to kind of start us off here a little bit tonight, is you want to be able to do logarithms of this sort without a calculator, okay? Just to kind of get you to understand what's going on. What the meaning of this problem is this. If you're doing the log base 5 of 125, you're just saying 5 to what power is equal to 125. That's what the meaning of that is. And when you remember, if you're doing a logarithm, you're looking for an exponent, right? What's the answer in your head? 3, okay? 5 to the third is equal to 125, so that's the answer, okay? You're looking for the exponent of 5 that gives you 125. Okay? All we're going to do tonight is just the super easy ones. Okay, the next one. 9, you're saying 9 to what power is 9? So what's the answer? 1. Okay, 9 to the first is equal to 9. So the logarithm base 9 of 9 is equal to 1 because 9 to the first is 9. Okay, the next one goes like this. We'll say 3 to what power is equal to 1? So what is that? 0. Okay, so what we're finding is 3 to the 0 is 1. That's what that problem is saying. What power of 3 is 1? Remember, you're looking for an exponent. Okay, now these get a little harder, and they start digging into your background a little bit. What this one is saying is this. Now, what I'm going to have you do on this is do this. When they start getting a little harder, I always recommend that you just set it equal to x to start with. And then we're going to write this in exponential form. So if you write this in exponential form, you would say 10 to the x is equal square root of 10. Okay, do you know what that is? A half. Good, it's a half. Okay, and see what this really means is this. It means 10 to the x, and we've gone over this and reviewed this. A square root is the same thing as a half power, right? So what you would end up having is you would have a half. 10 to the 1/2 is the same thing as the square root of 10. That's the idea. Does that make sense? So you got to know those rules for radicals. Okay, let's finish up just with these next two, and that's it. Then we'll work on the harder ones next time. So what I'm going to do on this is I got log base 5 of the cube root of 25 is equal to x like this. Now this one's going to take a little bit more work. So you would say 5 to the x is equal to, and I'm going to have you write that as 25 to the 1/3 power like that. Because if you're doing a third root, it's a 1/3 power. Okay, now this is what we'll get into next time a little bit. It's kind of hard to do this in your head unless you do this. You can take that 25 and you can write that 25 as 5 to the second. Okay, like that. Then what you would have from here is you would write this as 5 to the x equals 5 to the 2/3. Okay, because again, I'm doing a property of exponent. I multiply those exponents there. Now look at this. There's only one thing that x could be in this equation. What is it? 2/3. So when these problems get a little bit more advanced, you have to kind of set it up so those bases are the same. So the only thing that makes any sense on this problem is those two things are equal. So if the bases are the same, then the exponents have to be the same. So you have to kind of rearrange that, so that would be 2/3. Okay? That one's a little bit harder. So we'll take this and we'll finish this up next time. And the ones that we're going to do beyond here are kind of a little bit more like that. Okay?